Hello everyone. Today I will show the solutions to problems 5 and 6 of round 173 of the Prairie Math League. For problem number 5, we have a line with equation 12x plus 5y equals 60. Now this forms a triangle with the x and y coordinate axes, and we wish to find the sum of the lengths of the altitudes of the triangle. So here we have our triangle, which is formed by this line over here and the coordinate axes. So to find out the nature of the lines, we just notice that we can take 5y equals negative 12x plus 60 to get y equals negative 12 over 5x plus 12. So this gets this can let us find our intercepts, which are going to be at 0, 12 and 5, 0. Alternatively, we could have just found the intercepts by plugging in x or y equals 0 in this equation. Now that we have these points, we know that this is 0, 0. So this has length 12 and this has length 5. We already have two of our altitudes that are 12 and 5, and we need to find the length of this third one, which is drawn here in orange. To do this, we're going to exploit a useful area relationship. The area of the triangle can be measured in two ways. We can either measure it like this times this divided by 2, or we can measure it as this times this divided by 2. Now, 12 times 5 divided by 2 is equal to 30, but this is also equal to this thing, which is actually, notice that by Pythagoras, this becomes 13, because 13 squared equals 12 squared plus 5 squared. But this, anyways, is equal to 13 times, let's call this h divided by 2. And then we can solve for h to be 60 over 13. Finally, we just add these all up, so 60 over 13 plus 12 plus 5, and this is equal to 281 over 13, which is option choice E. Okay. For problem number 6, we have a regular hexagon with side length 6. So here's a regular hexagon, and it has side length 6. And isosceles triangles attached to every side. So for instance, this one, and each of these other sides has length 8. Now we're going to fold this to make this pyramid over here with this length 8 and this length 6. And finally, we wish to find the volume of this pyramid. So first, we can know that we want to, for a pyramid, we have with like just unknown properties. There is one formula that allows us to find the volume. This is equal to 1 over 3 times the height times the area of the base. What just happened? I don't know. Anyways, 1 over 3 times volume times, 1 over 3 times height times area. Now, we can find the area of this quickly. Notice that this is a regular hexagon, so each of these are equilateral triangles. The formula for an equilateral triangle is area equilateral triangle equals the side length of the triangle squared times the square root of 3 divided by 4. And each of these has side lengths 6. So we get 6 squared root of 3 over 4, which is equal to 9 squared root of 3. Therefore, the area of the hexagon is equal to 6 times, since we have 6 equilateral triangles, this is equal to 6 times 9 squared root of 3, which is equal to 54 squared root of 3. Now, we have the area, and we wish to find the height. So some software glitch causes us to mess up a little bit, but we can isolate a small portion of this. So suppose we take this, and the top of the pyramid. This will look something like 8, 6, and the height of the pyramid. And we can solve for h quickly using Pythagoras, because this is 90 degrees. So in this diagram, it kind of looks like this. And we can solve for h to get 2 squared root of 7. Now we have our area and our height. Thus, we can find the volume to be equal to 1 over 3 times 54 square root of 3 times 2 square root of 7, which is equal to 36 square root of 21. And this is option choice C. And we're done. Thank you for watching.